welcome to the chemistry class. The topic we are going to cover is 1.2. Last time we talked a little bit about solids, liquids and gases. Today we will try to build upon those topics and concepts. Alright, so let's get on with it. So let's take an example of water. Okay, it's very common, right? Element of life, that's what it was called, although it's not an element, right? So water exists in solid form as well as liquid form and in the gaseous form, or you can call it vapors, right? Or you can call it steam. Got it? Now in solid form, water is called ice. We all know that. In liquid form, it is water. In gas form, that's steam, right? Now, how do we change these forms? We talked about it a little bit, all right? You can change these forms. These are basically physical states of water. They can be changed by heating or cooling. Right? What's the meaning of heating? Heating means that we are supposed to provide energy, okay? Add energy. Heat is a form of energy, okay? Now, cooling means to remove energy, okay? To take away energy from the particles. Remember that? This is extremely important, all right? You add energy or you take away energy, right? For that, I have an example here. Hopefully, I think I uploaded it here. So yeah, let me get it here. Yeah. So look at this image. Very easy example. So you might have seen it already, all right? So here we have water. Basically, these are ice cubes, and they are melting. You put a thermometer here. As long as ice is there, the temperature would be 0 degrees Celsius. All right? So remember that. We will come back to this point in the future, probably in the next video. Ice changes to water when it is warmed. But now you might be thinking, if I just put ice in a beaker or in a jar or in a glass, okay, even if I don't warm it, the ice starts melting. So what happens is that the ice has very low temperature. So heat in the surrounding transfers from high energy point, or the point where there's more heat, to the point where there's less heat or less energy, which is basically ice. So ice starts absorbing heat from the surrounding, okay? And when it absorbs heat, it starts melting. But unless and until all the ice change to water, the temperature shown on the thermometer would be 0 degrees Celsius. So the 0 degrees Celsius is the melting point of ice. Is the temperature at which ice melts, okay? The temperature at which any solid, at this point it's ice, melts. We call it the melting point or the melting temperature. This would be different for different types of solids. We will come back to that topic or that point again. Now let's see in the next diagram here, okay? So what's going on? We had water. We started heating it. When we heated it, right, so water started changing into vapors. It's not boiling at this point, but a lot of water molecules are changing into vapors, and you can see those vapors coming out from the surface of water. Okay, so when water is heated, the temperature rises. Okay, simple concept, right? The liquid molecules start changing into gas or vapors. This process is called evaporation, the point when the liquid changes into gas. Okay, or liquid particles changes into gas particles. All right, that was easy. That's evaporation. Now if you keep heating, there would be a point when the water or whatever liquid you have would start boiling, and then you can check with the thermometer what's the temperature. If water is boiling, the temperature would be 100 degrees Celsius for pure water. Okay, water is boiling. At this point, water molecules or liquid particles are changing rapidly into vapors or gas particles. The only difference between this one and this one is that when it's boiling, the evaporation takes place much more rapidly, and you can see all these bubbles coming out of it. Okay, now evaporates faster, and at this point when the water is changing into vapors, you can call it steam. It's just water vapors at the boiling point. Okay, so you can remember that the thermometer is showing 100 degrees Celsius, which is the boiling point of water. It is a boiling point of water. Different liquids would have different boiling point. Okay, so you can say is the temperature, boiling point is the temperature at which a liquid boils. Very easy, nothing too difficult. All right, or you can say the temperature at which the liquid starts changing into vapor state or gaseous state very rapidly. Okay, so that's what you need to keep in mind. All right, now let's try. So you can also reverse this. Okay, all these changes can be reversed. How do you do that? Okay, so let's suppose we have steam here, which is just water vapors at high temperature. Okay, and what do? You cool it down. Cool it down means you remove energy. At the steam particle, the water molecules have very high energy. Okay, high energy. Everything is about energy, very high energy. You cool it down. Okay, all right, when you cool it down below 100 degrees Celsius, right, it would change into water. Okay, it changes into water. Now this process is called condensation. We call it condensation. Okay, this process is called condensation. You can see in winter, if you have window, all right, you move your face very close to the window, all right, and breathe on the window. The water vapors coming out, or the water vapors you are exhaling coming out of your lungs, right, they would strike the window, because window would be very cold in winter season. All right, so immediately those water vapors would change into water droplets. They condense into water droplets. That's condensation. Okay, then what happens is that if you further cool it down, all right, cool it, let's say below 0 degrees Celsius, So immediately what would happen, that this water would change into ice, which is a solid form of water. All right. Now this process is called freezing. All right. Or you can call it solidifies. All right. Very easy. So this is the reverse process of what we did here, right here. Okay. So this was melting and this was boiling. Now the reverse is condensation from gas to liquid and freezing from liquid to solid. The example is water. You can do the same thing with the different elements, different compounds, different type of substances. All right. Now if we look at it in terms of energy, steam would have very high energy, water would have less energy, less as compared to steam. Okay. And the ice would have out of these three states least energy, out of these three states of matter. Okay. Maximum energy, steam or gas, intermediate energy or little less energy in liquid, very low energy in ice or solid form. Okay. I hope you got that. Remember, don't forget to subscribe, and if you do have any kind of questions or any queries, you can put them down in the comments. Okay. Or my email is given there, so you can also email me. All right. Thank you. So yeah, let's move on. So far we discussed how the solid, liquid and gases, different states of matter, can change into one another. Okay. Now all substances no matter their nature, can exist as solid, liquids or gases. All of them. Ionic substances, molecular substances, elements, compounds, all of them. Okay. Even iron can be melted and it can even boil. All right. Let's consider some examples. Right. Let's put some substances here. Different one. Let's put the melting point here in MPT, means melting point in degrees Celsius, and let's put their boiling point here. Okay. So let's talk about that. So oxygen here, we have oxygen gas, O2 in the air. Its melting point is minus 219 degrees Celsius, which is way below the melting point of, or you can say freezing point of water. Okay. And the boiling point is minus 183. We would come back to this, right? So the oxygen gas would boil at minus 183, like 183 degrees Celsius below zero. Okay. Let's talk about mercury. You know, mercury is a metal. Its melting point is minus 39 degrees Celsius and boiling point is 357 degrees Celsius. It means that mercury is a metal, but it exists as a liquid at room temperature. Okay, we would come back to this point again. Right. Another one, ethanol. Right. Minus 15 melting point and 78 boiling point. So boiling point of ethanol is slightly lower than the boiling point of water. Okay. Now we already know about water. Let's put it here as well, 0 and 100. And then we have, let's say, iron. For iron, we have 1540 1540 degrees Celsius. This is the melting point, and 2900 is the melting point. Is the boiling point. This is the melting point, and this is the boiling point. All right. Even the common salt, the table salt, the NaCl, sodium chloride. Okay, the salt we use in cooking, sodium chloride, that has a melting point of 801, and a boiling point of 1465. I'm not saying that you have to memorize all of them, although I highly recommend that you do memorize the melting point and boiling point of water, and the boiling point of ethanol. You would use it at certain points. Okay. The rest of the values are just for reference. Okay, just to give you an idea that every substance, element, compound, metals, every substance would exist, or at least it could exist as solid, liquid, or gas. Okay. The main thing we need to consider is how do these substances, or at which state these substances exist at room temperature. So we need to consider the state at room temperature. Okay, room temperature. So instead of temperature, I'm writing temp dot again and again, so please don't mind that. All right. So usually we take room temperature to be at 20 degrees Celsius. Okay. Now you know that at this room temperature, at the room temperature, oxygen is gas. But at the same temperature, iron is a solid. Why? Because the boiling point of oxygen is much below the room temperature, but the melting point of iron is way above the room temperature. Okay, how does that work? I will explain that to you. Okay, for now just know that for iron it has very high melting point above the room temperature, right? So at the room temperature it is hard, strong metal. Okay, now if we compare iron, which is a metal, right, with another metal called mercury, right? So now mercury is also a metal, but it is a liquid at room temperature. Why? Because the melting point is below room temperature. Melting point below room temperature. Alright? So if we have a substance with melting point below room temperature, it would be a liquid. If we have a substance with melting point above room temperature, it would be a solid. The best example are iron and mercury. Iron has melting point, very high melting point above room temperature. And mercury has melting point below room temperature. You can see it here, below room temperature, minus 39. Water also have a melting point below room temperature, that's 0 degrees Celsius. That's why it's liquid at room temperature. Okay, please keep that in mind. So that was all about 1.2. Okay, now let's directly jump into 1.3. Again, this is slowly building upon the foundation of the table we did in the first lesson, all right, of solid, liquid, and gases. Okay, so we would talk a little bit more about particles, in solids, liquids, and gases, right? Solid, liquid, and gases. Okay, so we would talk about those particles, right? We already know a little bit about it. We discussed that. Let's kind of like very quickly revise it. Okay, so if we compare solids, and here we have liquids, right? And here we have gases, right? So let's talk about that one more time very quickly. So in case of solids, the particles are arranged, right? Let's move this slightly here. Okay. So particles are highly arranged, right? Usually the particles are fixed at their position. If they are crystalline solids, they might have, sometimes, not always, they might have a regular pattern. Crystalline solids do have a regular pattern. We call this pattern a lattice, crystal lattice. Okay. Why these particles are regularly arranged and they are very close to each other, closely packed, right? And what else? Vibrational motion only. They are only vibrating. Okay. Now, if we compare it with the liquids, the particles are not arranged, right? Particles can move. We talked about this before. Not fixed, right? They are close, or you can say they are less close to each other, right? The forces are very weak, okay? Weak forces of attraction. We talked about it. In case of solids, they are very, very strong forces of attraction. In fact, out of the three states, solids would have the strongest forces of attraction. Okay, I hope you got that. In case of gases, right? In case of gases, we have particles that are far apart. Particles move rapidly. They are far apart from each other, right? Much more space between them. You can say the particles can collide, right? With very high energy, very weak forces of attraction. You can call them intermolecular forces. Okay, so that's the major difference. Okay, now how do the packing change when a solid melts? Okay, so what happens is that in case of solids, right, the particles are packed together. Okay, I drew that. Okay, so what happens is that, let's say this is a solid, the particles are closely packed together, right, like that. They might ask you to draw it, but these particles are basically vibrating, right? Very like mildly vibrating at their position, all right? So, but they are vibrating, okay? Vibration, right? Particles vibrating, all right? Particles are vibrating. If you start heating them, right? If you heat them, give them more energy, so vibrational motion would have little energy, right? It use a little bit energy, right? But if you heat them, okay, sorry, heat them, give them more energy, so they start vibrating more, okay? So increase movement, so their vibrational motion increases, right? So what happens in case of solid, in case of liquid, the particles start moving here and there and rapidly. Sorry, a little bit faster, not very fast, but they are moving. Right now, they are also vibrating and they are moving randomly. Okay, so yeah, that's it. This is liquid, right? So particles are freely moving, not very rapidly, but they are moving. Okay, this process, as you know, we call it melting. Okay, melting. Okay, this is melting. All right, now what happened here? What happened during this process? Right, particles gained more energy, they started vibrating more, and the solid expanded. Right, solid expanded, the particles moved away from each other. All right, then solid changed into liquid. Very easy, right? Nothing too difficult. Then if you keep heating it and do not stop there, right? So what happens, let's say that all of this, like this solid was in a container. Okay, let's say this solid was in a container, right? So now it would be like this. So it's moving like that, right? Now what happens when you know keep heating, right? So when you keep heating it, right? So the particles will start changing into gas particles, liquid, from liquid to gas, right? So these particles, some of those particles are still here, while the other particles start going out like that, right? Into gas form, right? So why does that happen, right? If you keep heating, heat more, you are giving them more energy, and if you are giving them more energy, they are not going to sit there idly. They would start moving. They would start moving rapidly. Okay, so more rapid movement, because you are giving them energy. All right, so yeah, that's it. More like you heat them further, more energy, they move faster, they collide more, liquid expand. Okay, you can call it evaporation, right? If you keep heating it, the liquid will start boiling, right? So you can call it boiling. Okay, easy, right? To boil that, they would have to overcome, okay, they would have to overcome the forces of attraction in the liquid form, right? So what happens? They overcome particles, overcome forces of attraction in liquid state. Okay, and when they do that, they change into gas, right? They start changing into vapors, into gas, right? And if you heat them further, this process would increase and the particles start changing into gas much more rapidly, right? So now evaporation occurs at almost all temperature, even at very low temperature. Okay, but at boiling point, we call it BPT, boiling point, it is much more rapid. All right. So at the room temperature or slightly above the room temperature, below the boiling point, evaporation is taking place. The particles with more energy are escaping, but it's much more slower process. Okay. Another thing you need to keep in mind is that the amount of heat required to change from solid to liquid to gas would be different. Okay, amount of heat for changing or to change one state would be different. Amount of heat to change states different for different substances. Okay, what does it depend on? It depends on different types of forces. Okay, so different substances have different forces of attraction. Okay, or different strength of the forces of attraction. That's why it would take less energy if the forces of attraction are weak. If the forces of attraction are strong, it would take much more energy to break them and change them from solid to liquid and liquid to gas. Okay, so that's all about how do you change different states of matter. Okay, we have a couple of questions here. I would keep it here. All right, I don't want to make very lengthy videos. All right, I just want to keep it short, not more than like, trying not to make it more than 30 minutes. All right, so we have some exercise questions. I would add maybe 1 or 2 past paper questions tomorrow related to this topic. Okay, and the next we would go into heating and cooling curves. Okay, if you have any questions, let me know. Take care.